Welcome everybody to this Philly Tech Week event by Chariot Solutions. My name is Ken Rimple. I am a mentor and trainer and consultant at Chariot Solutions, and so I am bringing you a talk on AWS CodeBuild. CodeBuild felt a bit different to me, a little odd actually upon first use. I used things like Jenkins before, hacked a little with Circle CI. Some of the things are very similar, but not everything is easy to find the first time you're going through it, especially if you're not normally doing a lot of AWS work. So it helps to see a few working examples. It helps to see, how generally to get things tested and get things working. So I want to show you what I can. I'm going to give you about 45 minutes or so, maybe a little longer of lecture, and open up for QA towards the end. Feel free to put your questions in the chat. That would help. I really can't stop in the middle of some of this stuff to answer them in the middle because I want to make sure we cover all the topics. But I will be available for question and answer at the end. So thank you for attending. So again, this is me, Ken Rimple. Again, it's my main role here is training, mentoring, and consulting at Chariot Solutions. I do a lot of presentations about emerging technologies. So for example, when single page applications were coming up, I did a lot of talking on Angular JS originally, Angular, React, a little bit on Vue. I switched over to doing a fair amount of work in AWS because that's what a lot of our clients are using these days to roll things out. And I figured I would jump in that side as well, since I have a very long background in server-side development with Java and Groovy and other things like that. Briefly, other content that Chariot has, I want to make you aware of. If you go to Chariot Solutions YouTube site, which is youtube.com/Chariot Solutions, if you hit the playlist button, you'll see my podcast with my silly laughing face there. I run a podcast that's actually happening today at noon called Tech Chat Tuesdays. We have a whole series of podcasts called 15 Minutes With, which is 15 minutes with tech leaders and developers and people who run businesses by Tracy Wilson-Rossman and others. We also have all of our content from all of our Philly Emerging Technologies for the Enterprises conferences online. That's something I've worked very hard at doing for us over the years. And so this year we did Philly ETE 2020 virtually, but we have all the videos available there. If you go back further, you'll see 2019, 2017, 2015, 2016. They're all there. And also a lot of our other special things. For example, we did a full day on single page applications. There's a playlist for that, as well as for an IoT event that we did recently as well. So a lot of free resources. You don't have to register at all. Our blog is chock full of really great content by our developers. Lots of really good meaty topics in AWS and server-side Java, Scala, Clojure, all sorts of stuff, React, and so on. We also have, let's see, the podcast itself. I'll look the feed. So this is the Chariot TechCast. It's been running for about 10 years now. And that is available online. If you search for it on any podcatcher, you'll find it. And so, like I said, there's a lot of resources available to you. We feel it's very important to give back to the community, both in Philadelphia and in the wider community in the world. So I thank you for spending time with us. The next major talk that we're going to have coming up is a big one for us. It's Java at 25. We're going to do this on October 21st at 3:15 p.m. Eastern. This is a retrospective on Java at 25 with our consultant, director, CTO, Aaron Mulder, and myself, asked questions by Tracy Wilson-Rossman, our director of marketing. And then we have a great special guest, Brian Getz, who has spoken at a number of Philly Emerging Tech conferences. He is a Java language architect at Oracle. In fact, I think he is the Java language architect at Oracle. So you get to hear from him where things are going. And if you do sign up for it, it's a nominal fee, I believe. And we partnered for some companies, Lacombe and Workhorse Brewing, for some discounts on their coffee porter and for the coffee. So you can join the happy hour and enjoy either coffee or a beer. All right, so enough about marketing ourselves. I did want to do that, though, because I think there's a lot that you can get from Chariot just for free and see what we're all about. So let's talk about CodeBuild itself then. What is AWS CodeBuild? Well, first of all, it is a cloud application builder. So it runs in the cloud, it runs in AWS, and it runs as a compute engine. So basically think the Docker container with preloaded software that can run your build. It works similar to Jenkins and Circle CI and other tools where it has a life cycle, that starts up, it installs things, it sets up things, it runs the build, it cleans up after the build, reports on things. So we'll look at that. It can pull code from code commit, which is AWS's Git repository, or GitHub or GitLab or some other places as well. Basically Git-based version control. And it can be used as part of a wider pipeline using AWS Code Pipeline, for example. Let's look at some of the terminology before we begin. I want to make sure we kind of get that out of the way. So build specs. The main thing we're going to talk about here is the build spec. It is the meat of what you're doing in a code build. You're building your code. So the build spec is the thing that tells you how your code is built. It's a YAML file, indented, spaced text file, and that file embeds a script and embeds settings to run that script that are interpreted when the build spec is run. A code build project is the entire code build process for that particular project that's being built. So the build spec is the thing that runs, but the code build project defines where do we get the code from, what kind of machine are we building it from, and what are we going to do once things succeed or fail. And what is the build spec file? Where does it live? So all those things are defined in a code build project, which you can then use in the AWS console to manually trigger a build or to check on the status of a build run. A report is what you think it is. It's a content of some sort of output. And so the main thing is it's like Circle CI or Jenkins in that it wants some sort of programmatic piece of information. It wants like an XML file. So for example, traditionally you'll try to set up a JUnit XML report as a way of registering a report where you can actually look at whether things passed or failed in a graphical way. So you can wire up a report in your build process and then in your code build project point to where that project is in the build spec to say this is where my report is. So when you get this information, report on it in the code build project console. An artifact is something you build. So for example, if you're done building something and you want to archive it somewhere, you can archive it as a build artifact. This is useful if you're going to use code build by itself. So you can actually have it build and upload to an S3 bucket or something along those lines. And so the build artifact is what is placed there. A build run is what you think it is. It's when you kick off a build, what are the actions that have happened for that build? What are all the steps it went through? What were the parameters that were sent to it? What version of the code are we working against? Did it pass or fail? And so on. And that's all available for view, either from the CLI to get information or from the console. And you can also report on the status of build run by setting up build notifications. So why use code build over something like Jenkins or Circle CI? Well, first of all, if you need to access internal AWS resources, one of the projects I worked on, we were really working down the road of getting a good web testing code build going. So we wanted to hit up our application and make sure that we call all the different user elements. So we were using a tool called Cypress to do that. Of course, the website is available publicly, but we needed to reset a database on this particular AWS instance of our app. So we used AWS commands to go ahead and configure things and reset things in the environment. And so that's one of the reasons that code build is useful, is that it has access to those things. And you can define the rights and privileges that the code build can have in your AWS cloud environment in a very fine-grained level of control, which is the way you should be thinking about security in AWS. Maybe you need to run tests that live within a VPC. Maybe you want to, do builds or tests or run JUnit assertions against code, like integration tests. But then you also have to run different operations within the VPC itself on a live server. You can do that. You can configure your code build run to run against a particular virtual private cloud. Maybe you need to deploy resources or, again, communicate using the CLI. Those are reasons. Also, you may want to use a wider code pipeline project. And so code pipeline integrates with CodeBuild to do the actual guts of the build. So if you want to have code commit for your version control, code pipeline, orchestrating builds to CodeBuild from code commit source, and then deploy it using, ECS or an EC2 image or S3 content, you can use code pipeline, and CodeBuild works very, very well within that. It was built for that purpose. If you don't need access to all these things, if it's just something where you're building something and then you're copying it somewhere to be deployed, and it's a tiny amount of work, you could use Circle CI or Jenkins. You could still choose those in other cases. You'll just have more work that you'll have to do to configure outside of AWS to set up your AWS configuration. And you won't necessarily have access to things inside the VPC unless you decide to install Jenkins within the VPC in some sort of server. So this is something that's already ready for you to use. Let's look at some of the elements of a CodeBuild project. All right, so what we're talking about here is, for example, the build spec itself. Now, the build spec itself is, something that is a YAML file, as I mentioned before. Here's an example coming up. So the CodeBuild executes this build spec file. It can either live within the project, which makes it easy for you to test locally, or it can live within an S3 bucket, and you can reference the S3 bucket and the location within it when you set up your build project. The default file name that it looks for in CodeBuild is buildspec.yml in the root of your project. And here's an example build spec. It should start with a version declaration. In AWS, there is an older version of CodeBuild, version 0.1, less features. They tend to leave things available for you instead of getting rid of them in AWS. Not all cloud providers do that. Many cloud providers will actually, tell you this is sunsetting in a month or a year. But AWS generally keeps things on for as long as possible. There are very few things they actually just stop letting you have access to. So version 0.1 is still available, but version 0.2 is the current version. And then the build spec then has phases. And so the very simplest build spec here is a phase build with commands in it. And you'll notice that we've got these YAML, it's a list of statements. Those are a YAML array or list. And they're run one by one. And if any of them has a bad return code, as we'll see soon, the build fails. And we'll talk about what that means in a bit. The phases also include install, pre-build, and post-build as well. And there are other settings in here that we'll get to later for things like reporting and the artifacts. Now, what about the project source? So again, we need a Git-based project. What'll happen when CodeBuild runs, once you define your CodeBuild project, is you'll tell it where that source is. And when you kick off a run of the CodeBuild project, it will pull down the CodeBuild project version from Git based on the tag that you specify, a commit or branch, depending on your provider. So you might have like a latest branch, or you might have a candidate branch that once you push to it, you trigger a code build. You can also, by the way, use a webhook there to say, oh, when this happens, go ahead and trigger a code build. That source code in that Git repo is the root of the build script. So the idea is it will deploy this thing and it will drop it in, and it will use that as the root of the directory structure for the build. And that's what the CodeBuild build spec file will see in terms of files it can access. And again, you can use GitLab, GitHub, Code Commit. Those are some of the source code management systems CodeBuild can integrate with. Now, all builds will go through several phases. As I said, install, pre-build, build, and post-build. They are pretty self-explanatory, like most build tools have. And then you will have build artifacts and reports. The build can be published as an artifact, as I mentioned before, to S3 or other locations. And reports can be generated after a successful or failed build. And you do want that for failed builds because you want to see, for example, if unit tests failed or integration tests or web tests failed. And they can be in multiple formats, but JUnit XML being the most common one you'll run into. A lot of build tools can report to that format. You can also get notifications through SES simple email service, and you can notify about build lifecycle events. It can also report build success or failure to your source code management system. So for example, whether, it has failed its last build, and, things like GitHub or code commit should be able to do that. We're not going to talk about that here. We just want to talk about the mechanics of code build, but I'm giving you the wider view here. All right, so let's say you want to get started. Let me give you a recommendation. The first recommendation is make sure your build works perfectly locally. I know that sounds a little dumb and obvious, but remember what you're doing when you're running a build on AWS. You're spending money. Okay, so it's going to cost a little money each time, and there's a free level, and once you pass that free level, you're going to start paying. But still, accruing billing to debug your script itself is probably not cost effective. And I've been there because I didn't know how to do what I'm about to show you. So if you can learn how to build locally, to test your build spec locally, it is going to save you an awful lot of time. All right, so if you want to run it locally, you can use a Docker image and a script. So I've given you here, and I'll point to the slides at the end of the presentation. I've given you here a reference to a CodeBuild build.shell file. And that particular shell file is made available by Amazon Web Services as part of their Docker images project, which we'll come back and look at. But this thing actually will run a CodeBuild agent Docker image, which basically acts like the CodeBuild engine. And it will then use an engine that you've built, an AWS CodeBuild operating system Docker image that you build and install locally to kick off your build locally. So you're basically running in a Docker container on your local machine. And I'm not going to go too deeply into these switches because I show you some of these in a few minutes. There is a good set of instructions for building the AWS build image on that project. So you can take a look at those. And the image you're going to build depends on what type of build operating system you want. I'm just going to explain that by using this. Let's see here. So the AWS CodeBuild Docker images, they have Amazon Linux 2. Amazon Linux 2 is a common Amazon image for running Linux containers. You can run it in EC2. You can run them as Docker containers. In this case, that's what we're doing. And this is a custom version of Amazon Linux with a bunch of languages and operating environments installed in it. And so the current version of Amazon Linux 2 is version 3. Amazon Linux 2 version 3. Okay. It is built with a Docker image, and it has a bunch of tools in it. So I only point that out because that gives you an example of some of the ones that you could build. You also have, for example, Ubuntu. So they make Ubuntu images like the standard 1.0 to 4.0 Ubuntu images that they have installed, as well as some unsupported ones that are very specific for, different things that you can try to use. You can build any of these, install them locally to debug your build spec. Now, the point I'm making is if you do it there, you're not spending money on AWS during your debugging process. And it's a lot faster. When you build with AWS itself in CodeBuild, you have to go through a console, submit the build, watch it fire up a container on the cloud, which could take some time, have it run for a certain period of time, and then output an answer to you. But you're doing it through AWS, and it could take minutes. It's pretty immediate kicking off the CodeBuild image on your local Docker machine. So that's why this is important. Right? So you want to diagnose problems with the build spec in your CodeBuild locally, because there are other things you can't easily do locally. Like, for example, debugging the role that you're setting when you're running a build spec in the cloud. You kind of have to do that in the cloud. Save yourself some of these cycles and build locally first and test in your local Docker container. Now, I have an example in the project I'll send you in GitHub. And this is an example of a script that uses that CodeBuild build shell and automates it. This is assuming that you've already built a Amazon Linux version 3 container in your local environment using Docker build, and you've given it that tag. All right, so if you go in, you go in the Amazon Linux 2 version 3 image for AMD 64, and you do a Docker build, you can follow the instructions online for that. You can build it with that tag, and now you can use this script and directly run a code build image from Docker on your local machine. Now, let's go through the flags. As I mentioned, -I is the image. This is your local Docker image in your Docker machine on your computer. If you specify artifacts, this is another thing. If you're going to publish artifacts when your build is done, you want to make sure they're in the right format. So what you can do is you can say, I want to download the artifacts when the Docker container is done to a directory. You can pre-create this directory somewhere. I put mine in the temp directory, like temp code build. And it will drop whatever it would upload into AWS in the location you're planning on placing it in that directory for you to review. So you know whether your code build gives you things in the right format. -S is where are the source files that we're going to operate on. I mentioned before that code build itself checks out your project and then runs it with the build spec, seeing that as the root. That's when you install a code build project. We're only talking about the build spec right now. So we're setting up the minimum settings that would be in a build project so we can run in a Docker container. So -S, and then I tell it to do the Unix evaluation of my current working directory, which is where I'm going to have my file. There's also a -C. This is critical. So if your code build, and it usually does, uses different credentials to get things done, when you run in Docker, you're not logged in necessarily in the Docker image. But you can tell it to take your current desktop's AWS credentials from the .aws/credentials file in your home directory. And that's what -C does. And it will take those and use those as the authentication while running the code build. So if you've got a power user set up for Dynamo and your code build writes Dynamo tables, and you're doing that from your own local machine through the CLI or what have you, you can do that through the code build that's running in the Docker container, which is really handy. And -M says, instead of copying the files into the Docker container, which is slow, -M does a volume mount. So it's nice and quick, and you're directly operating on the files in the project referenced in your local file system from the Docker image. So it's relatively fast. There's also another option here. And so I have to take a brief look because I forget what it is. -B for build file. If you have not used /buildspec.yml in the root, you can do -B in that script, and -B will point to that particular file as well. So that's the hidden option here that I haven't showed you. It's in the project itself, though. All right, so let's run a code build on the local machine. Let me get a computer image up and running here. So I'm in a project that I'm working on, kind of like a hacking around project, but you'll get a version of this that has the Angular demo in it. I have an Angular app hosted on S3. And so what I have here is I've got a run in code build script. That's this script right here. You'll notice what I do is I look, if you're not a shell bash user, I'll walk you through this. This little chunk of code says, if I didn't pass it an argument, and I don't have, if I didn't pass it an argument, I want to set the argument to build file of build spec YML. And my point here is that I'm going to make an environment variable called build file that I'm going to use here. So if I don't specify one when I run the Unix script, it's going to just say it's build spec YML. But if I do specify one, whatever file name I specify is the one that it runs. So if I run my run in code build, I'm going to pick some sample images. And let me show you some of the build specs here. All right, so let's look at the simple build spec. I mean, the most simple build spec you can have. It's just got an echo in it. So I'm going to go demo build specs, simple build spec. And let's get this thing to the full. You can see it's doing a Docker run. In the Docker run, all the parameters are there. It then says, I'm going to walk through this, that it launches an agent. And the agent is the thing that actually launches your container. Now, notice that in the -I, I'm saying the container you want is Amazon Linux 2 version 3. So it launches that Docker image, and then it starts the build process. And you can see that it kind of short circuits the download source, because what it does is it basically mounts a local volume. So this is a local mount of a source volume that we have here, which is our current directory. It sees the YAML location we pointed to. And then it goes through some substitutions, and eventually it analyzes the YAML and says, oh, there's one build command. So it moves past the download source step, because that's really not happening. It's just a local mount. It enters the install phase. I didn't tell it to install anything, but that's succeed. It then enters the pre-build phase. Nothing's going on there. It enters the build phase. It sees the echo high. It runs the echo command. It returns high, and nothing failed there. So the build succeeded. And that's it. You can always ignore that abort on container exit. That doesn't matter. To truly know whether it worked, you can do echo $? On Linux or OS X, and you'll see that that is a return of 0. If it failed, it'll be a positive return number, like most error control systems. But here's the cool thing. I didn't have to go to AWS itself and run that build spec. All right, so that's a real simple run of a build spec. It's just kick off a shell script that runs CodeBuild build.shell after you've installed a Docker image that you want to run that matches one of the Amazon Linux or other operating systems that could run in CodeBuild. And by the way, quick note, if you read that project site for the custom CodeBuild images, it tells you how to build your own image and install software yourself, which can be very handy. All right, but let's talk about defining a build project itself. Okay, you want to define a build project, you're going to have to set it up in one of two ways. Either through a convention of configuration as code, whether you use CloudFormation, CDK, maybe Terraform, or the AWS console. I want to warn you off of using the AWS console, except for just learning CodeBuild. The reason I want to warn you off it is, if somehow that gets deleted, you have to go through all the manual steps again. Or if you've been running in a particular AWS region like US East 1, and now you want to launch in the West Coast, you want to launch because you're going to have customers in the West Coast, and you want to launch all of your infrastructure there. Now you've got to do it all over again in another environment, which, another data center, and you don't have that script available to you. So CloudFormation is the primary way that we do configuration as code, and we use this all the time at Chariot. We also do use Terraform in some projects, which is kind of another open source multi-cloud provider configuration as code tool. And they now have this CDK, the development kit for basically automating the configuration APIs. That's about, I think, a year old, and that's another contender for this. But you basically write your code in a programming language to configure things. But for now, the de facto standard and all the documentation you can find, much of it is written in CloudFormation, which is why I'd recommend you learn CloudFormation. It's not a simple lift. It will take you some time. But once you learn CloudFormation, it unlocks a lot of configuration for you as an Amazon Web Services developer, and makes your life a lot easier once you wrestle through the syntax and get used to it. It's really worth your time. All right, so there's my recommendation. Always use CloudFormation to configure projects so you can tear them down and set them up again easily. It's really the de facto way that you get things done in a very AWS-centered environment, with, I would say, the alternative mostly being Terraform. All right, so now running build specs in the CodeBuild console, you'd have to have a CodeBuild project installed. I have done mine through CloudFormation, which has configured where the source repository is. It's configured a identity and access management role in Amazon, gives you the ability to do things in the cloud. It's configured the build spec. In my case, I'm pointing to it from a directory and file, and then configuring other aspects like where the reports are, alerts, triggers, etc. All right, so I have a bunch of examples of this stuff out there. So let me just take you through running it first, and then we'll go and look at how we configured it. So just give me 1 second here while I get my AWS console up and running. All right, So I'm in the AWS Management Console. I'm going to CodeBuild. There's a nice little services if you haven't done this before, but services, and you click that and it will let you search. All right. And here we see a simple demo project. This will be fun. It failed. So I think I know why it failed, actually, because I made a change and I'm using it in code pipeline as well. And that's not completely wired up. And so that failed. So let me show you what this is. So we've got this build project, demo Angular stack, Rimple code build. If I open this thing up, you'll see that it's got, in build details, it's got a project ARN. It's got a source. Our source is a code commit project, a Git project in Amazon. That's the name of the source repository. If I look at that source repository, it's just a project, an Angular project with a build spec in it and some scripts to run the build spec. Also some CloudFormation as well. And then, so, you know, we have environment settings. For example, we've got a hosting bucket name for when we created this project. We gave it a name for the S3 bucket where the website was hosted. So when the build runs, we want to copy the updated content to that website as the example that we're doing. And I need to set that as an environment variable for the code build to run. Then we have the build spec itself. It's saying that it lives in Angular app build spec angular.yml. And we'll look at that a little bit later. And then we ultimately have artifacts we're going to upload to, and we upload those to an S3 bucket that I create when I run the code build, the CloudFormation to create all these items. We've also configured CloudWatch logging so we can take a look at logs. All right, so that's an example of the build spec and the code build project it lives in. I'm going to click on Start Build on the right. And this gives me an option to, you know, either run it as a single build or kick off a number of builds as a batch. It has a timeout of 10 minutes, which is extraordinarily long. This thing takes about 3 or 4 minutes to run max. But, you know, you do want a timeout long enough to run your build. Otherwise, it will fail your build because it took too long. You know, if I didn't care about artifacts for the project, I could turn that off. These are all things I could feed to it as default settings in the CloudFormation. Now it's going to load it from the source code in the source provider. It wants to know what branch to use. I'm going to pick master. And I'm going to look at the environment variables. I could override the hosting bucket I'm uploading to at the end. I'm not going to do that. I'm going to just bring that back up. And I'm going to click Start Build. So Start Build now, I can go away and do something else and come back later. I could also configure it for notifications. I'm not going to cover that in this talk because we have a limited amount of time. But this is now kicking off the build. We'll come back to that in a little bit. Let's take a quick look at the CloudFormation. Now, the CloudFormation is a little bit complex because it does need to know certain things that are kind of AWS basic stuff that it takes a little while to master. But there are a lot of templates out there. Amazon themselves have a bunch of templates for things like CodeBuild. But I tried to give you one that was kind of distilled down. So you'll see in your project, it's the Angular app. There's a CloudFormation YML file. And let me just make that full screen on this thing and make it large. Okay. I'm just going to collapse everything down. All right, so we're going to give it a, when we build this whole thing, I have pre-created a code commit repository with the source code of what I'm doing, my Angular app and its other stuff, build spec and so on. So I'm going to give that as a parameter when I create the stack. CloudFormation creates a stack of software. And so that stack of software in this case is going to be an S3 bucket to serve the content, an S3 bucket to hold the artifact, if we want to look at it for later to do something else too. And then also it's going to have the rights, the role, and the rights for the S3 buckets and other things to get things done when CodeBuild runs. And then we're going to have the CodeBuild spec itself. So that's what all those 5 things are that are resources. So I'm just going to collapse these down and show you. It's just 5 specific elements. So we need a S3 bucket, This is the one for web hosting. That code right there is all you need to do to create an S3 bucket and have it publicly hosting content for you. Actually, it's not all that. There's one more thing to do too. There's the bucket policy. And so, for example, we've got website configuration and bucket name, things like that. Some of these settings, we have public read set. So public read being set and the website configuration will get you most of the way to having a publicly hosted content bucket. All right. Project artifacts bucket is just the bucket we're using internally. So we're not going to worry too much about any other settings for that for the time being. If you were really doing this for real for both of these, you would enable deletion protection, which is another property that says, please don't delete these if the stack goes away, because I don't want to lose my web hosting bucket if I'm tearing down the stack. Maybe. Then we have a bucket policy, and this bucket policy adds the permissions for the website so that when it tries to look at files within the bucket, it can see them. So this is basically some semi-complicated syntax, but it's not the worst in the world, that says we are going to have a policy attached to the hosting bucket that allows us to do S3 get object no matter who we are, and that is on this ARN, Amazon resource name syntax of an S3 bucket. These can be defaulted with this particular bucket name. And that's the name of the bucket that was created here. So some of this is complex CloudFormation stuff. I apologize in advance if it's a little bit too dense, but it's there for you to review. The other thing you have to do is you have to set up an execution role, and this is a role that runs when your code build runs. So I have an example of that there. The stuff in the beginning is kind of required just in general to run code build. So for example, you need to be able to kick off the EC2 container instance of the code build. I think they do use EC2, but the CloudFormation settings, and then you have the policies. What is the code build going to be allowed to do? So our code build is going to be manipulating the hosting bucket. So I have some permissions here for that. We also need to be able to do logging. I have permissions there for that. We also need to be able to access code commit to fetch the code. I have information for that. I have to be able to write a report. So I have configuration for that. And so those are the policies. So yes, there's a lot here, but it's better to do it here than to do it by hand and mess it up the next time. Then you have the code build configuration. You'll notice here, we've got a type code build project. And I won't go through all this because it's too long. We won't have enough time, but it's there for you to review. And you can see generally that, you're listing where the artifacts will be loaded. You're listing how the logs are going to be written to. You're telling it what type of container it's going to use. You're telling it any environment variables. That's that hosting bucket name. That comes from the name that was created for the hosting bucket. And then you're telling it the source code. And also you're telling it the build spec. What build spec am I using? And in this case, I'm using the Angular app build spec Angular. And there's my timeout, okay? In the end, CloudFormation can output information. For example, what website URL it's gonna host on. And there's an example of how to get that from the S3 bucket that's doing web hosting. What's the S3 bucket name we created? Because we're not giving it a name, we're letting Amazon create the bucket name. So that'll be outputted. What's the code build project name and the artifact bucket location? All this stuff can be accessed from the Amazon console. And I'll stop talking about this in just a second, but I just want to give you the basics here. Where's my console? Here it is. So if I go to CloudFormation, if I look at outputs, those were the 4 outputs. All right, so those were all the resources it created. Those are the outputs. And I automated creating these things. When you take a look at the project, you'll see there's a deploy with code build. And that script actually, and I'll put this information in the README after I'm done with this today. That information is how you run a CloudFormation deployment. All right, with all that said and done, let's get back to the task at hand. So build spec tips, these are important. Any non-zero command result is going to fail your build. So if at the end of your build in a post-build step or something, you were uploading something, it's not going to do that. If you were going to use this code build in a code pipeline, and then you were going to take whatever was built and deploy it to an EC2 container or ECS container, it's not going to do that. All right, so it expects your statements to execute with a 0 return code. Any command, even little shell commands that return a non-zero, fail the build. And this can be hard to debug. Briefly, if I go back to this, if I do whoops, everybody, I just learned how to do whoops. So bad build step. Let's see what this does. I'll kick that off. If this runs in the cloud, you'll see that it fails, but it's not going to be obvious why it fails. All right. So, you know, in this one, let's see what I did here for the bad build so we can see what kind of error handling I had. Right? None. So that's a problem, right? Echo. It's better, and we got a 1 back from CodeBuild. You can go ahead and do echo $? In the build spec, right? Run it again. Kicks it off. Let's see here. LS foobar. Ah, look at that. See, it blew up. Okay. So this is the kind of stuff that you have to think about. You have to think about how you handle your problems, or echo, sorry, hold on. So in for example, you could do, oh, well, that's dumb. Sorry, let me do that again. Wrong order. It's a list. Try that again. LS foobar echo $? This will give you a better answer. All right. Now, notice it didn't get there. So it blew up because it in the build step, it failed. So you can do things like or echo not found. Let's try that. Excuse me. You can start to see that this is very productive. If you have to do this in CodeBuild itself, now notice that worked, right? Succeeded because we had an exit situation to say, you know what, if the LS failed, let's do something successful so the command line doesn't get an error. All right, so that's a positive thing. If you had to do this from the console, you would have had to create a build project. You have to keep checking in your build spec and then going through and triggering it and over waiting for Amazon to schedule and run your build. This took seconds. So that's tip number 1. Any non-zero return is going to fail your build, right? Even a lowly ls command, as we saw, right? It returns a 1 if there's not a directory that it's trying to access. Not something you would think about normally. Oh, okay, I got that wrong. Who cares? But the build worked. Well, it did, but the command return failed, you know, from one of the steps, and so that means it fails the build. So that means you should think about organizing your builds, modularizing your builds, making them smaller, perhaps, by project or module. Create shell scripts to run the guts of your build, and make sure that they handle errors appropriately. You know, if it's something where there's an optional thing that happens, but the directory isn't there, well, fine. So just, you know, don't have that cause the script to return an error. Return a 0 if it worked. And if you do return errors, make the numbers mean something for you and echo some content to the log so you can see what's going on by just doing an echo. Also, some of these scripts can be used for local developers. So if this thing sets up things for you and they're using Amazon CLI resources, they can run them too, right? So they can certainly run them just as regular scripts in their environment. And then orchestrate these smaller build chunks with code pipeline. Smaller, more modular builds are easier to orchestrate. There's less you have to change at a time, and they can be shared. All right. Now, from your language and runtime perspective, you want to set a language. You can use the install phase in the section called runtime versions, and you can tell it what you want to install. You have to make sure that that language is available for the container you want to use. It'll then make sure that's installed. It'll activate it for you, and then you can trigger things from it. So if I take a look at this little tiny URL link, this will get you started on that. Once I find out where it went. Let me click there. There we go. So this link goes to the AWS CodeBuild docs, and there's a table here. There's a scrolling table. It's not obvious. But if you need a specific version of a language, it will tell you which container images that you can pick that and what versions they have for each one. So Python, Java, Ruby. Corretto, by the way, is Amazon's JDK image. And so they're the ones that they support. You can use OpenJDK if you want to, up to 11. And if you need something other than what's on here, there are options for you. But here, let's just take a look at this briefly. So there's my code. There it is. Okay, so install runtime versions, Java. The version is Corretto 11. NodeJS version 12. And then from this build, I could use NPM because Node includes NPM, and I'd be on a version of 12 for that. Java, nicely, they include Gradle and Maven as tools out of the box because they figure you're doing builds. So that's what you would put in before your build phase. Phases, install, runtime versions. You can also add pre-build and post-build and finally sections. Post-build would run if it worked. Finally works, runs every time. Pre-build runs before the build if you have to generate source code before building it or something like that. So here's an example I used when we were running Cypress. So we were running Cypress web testing on a project, and we were going to, at the end, kit up all the reports that it ran. There were some really nice reports for Cypress, and we wanted to make sure they were included. So we did an NPM run of the commands to merge all the report settings in the JSON files and turn it into a beautiful HTML report and videos and screenshots. All right. If you need to, for very small targeted things, you can install software in the build image in the build spec. You can even tell the container to run as root if you need to do an actual physical build. But again, I wouldn't necessarily recommend this because think about what you're doing. You're running builds to build your build environment before you run the build itself, which means you're paying money for that, right? Over time, that could get, you know, needless waste of money. So it's better to actually create your own Docker image and upload it, build image, and then you can use that from CodeBuild. And there's instructions on how to do that, but it's a pretty advanced topic. Here's an example. For example, if I was going to run the Amazon Linux container and run yum, which is the package manager for that, to install pandoc. Maybe I'm generating documentation from ASCII doc to HTML, for example, or Markdown to HTML. Well, pandoc is already a binary, I think. It's pretty quick to install. So I can do that. If I have a chance at some point to bake it into a container, I probably would. And don't build like X11 or something here. You're just asking for trouble. You can even run Docker in the CodeBuild. So I believe this is probably why it runs as an EC2 image instead of a Docker instance when it runs in CodeBuild, but I could be wrong about that. I lifted this code from something I worked on before, signing in to get an ECR Elastic Container Registry login based on my profile so that I could access a Docker container that I might be using. So you could log in, you can tell it the runtime version of Docker is currently 19 is supported. And then in pre-build, you can sign in. Now I can fetch any image from my ECR, my Elastic Container Repository, and I could run it, or I could publish to it if I wanted to, right, with a Docker push, and point to the ECR, the Elastic Container Repository. Advanced topic, just wanted to point it out. If you do this, you must tell the CodeBuild configuration that you're running as root. All right, so that's all the stuff that I have in terms of slides for today, but I will take questions. But before I do, I just want to point out CodeBuild is a huge tool with a lot of settings, and it's part of a larger suite with Code Pipeline, Code Deploy, and Code Commit. It is AWS native. It can access all your applications if you need to through running it behind a VPC, for example, to get to your databases, your app servers. It can run customized build containers. You can test them locally. You can install CodeBuild projects through CloudFormation, which I highly recommend. And yes, it is complex at first, but if you're going to be working every day in AWS, I think CloudFormation is one of CloudFormation and the CLI are the two most important things you can learn as an AWS architect or developer, because you're going to use them all the time. And you're going to see samples in them all the time. So you should think about CloudFormation as a thing you should learn if you're becoming an AWS person in your day-to-day projects. And you can, again, use CodeBuild as part of a larger build pipeline. So with that, I'll take your questions. There are some links. I will make sure that I tweet out on @TechCast the location of the GitHub project, which has these slides in it. So let's see here. I do have one thing in the chat. Let me see what it is. Okay, it's Becca telling me it's time to wrap up. Thank you, Becca. Does anyone have a question? If you want to, I can take them through chat. I see some familiar faces here too. Okay. I'll just wait a minute or two. I have a chat question here. All right, Joel, thank you. All right. Again, look at @TechCast. I will tweet out all this information. But beyond that, I really thank you all for your time.